Let's go in and discuss Elm now. I'm going to go ahead and use codesandbox.io, which is basically VS Code in the cloud. I'm going to go ahead and work in Elm Playground. What I see here is a fairly simple application. I am going to go ahead and have my main be a browser sandbox. This is going to basically allow me to have a HTML page that can't interact with the outside world. We're going to say that our data for our application is going to be an integer. In Elm, we have a model that contains the entire state of our application. We have an init routine. So our init routine is going to be fairly simple. It's just going to return us an initial model. It's common to do type declarations for all of your functions, although it's not required. The type declaration uses a colon, and then you put the parameters separated by arrows and then the return type. So init's going to just return a model, and the actual declaration of it is that init, and we just use equal and give the declaration of it. So in our case, all we need is an expression that returns a model. A model is an integer, so we can just return a 0. Next, we're going to declare a type for some messages, which are going to be what are sent from Elm to the update function. When we have our HTML page, any actions that occur are going to generate messages. And then those messages are going to be sent to the update function. Let's just look at a particular message. We're going to have a counter. We're going to have 2 different values for the message. The message can either be the increment that has an associated integer or decrement that has associated integers. And then we can declare first our update method. Our update method is going to take 2 things. What it's going to take is a message. So that's the first parameter. And then we use an arrow. And then we have our second parameter, which is a model, and its return is a new model. We take a model and a message and return a new model. Now let's look at our update. Our update gets past these 2 parameters, our message and a model. We're going to go ahead and do a case statement in the message based on what type of thing it is. If we have an increment, then we're going to extract. This is a pattern matching, really. It says message, let's extract out the increment and whatever the value is, the delta. And then we have an arrow. And then we have our expression that is the value of the update message in this case. For us, the expression is just model. So we get this lowercase model, which is the value, the current value of the model. And we want a new value. Now so what we want to do is return model plus 1 because we're incrementing. We don't need a return statement because everything in Elm is an expression. And then finally, well, we'll come back later to the decrement, which we haven't put in yet, but we really should. Like Python, Elm is indentation sensitive. The view gets a model. Let's go ahead first and declare it. Type, right there. The view is going to take a model, and it's going to return a parameterized type that's basically HTML that can actually generate a message as we've defined up here. We're going to get given a model. And what are we going to do? Well, now we're going to just return some HTML. We're going to use here this HTML. And HTML is generated using just functions. Let's use a simple example. Let's just put in a div. And div is a function that takes two parameters. The first is a list of attributes, and the second is a list of children. Let's put in some text. And text, as we'll see here, is also a function that takes one parameter. The reason for that is this is a string, and we want to actually be generating HTML. So let's just try this. I'm doing a save, and for some reason it's not building. So let's go take a look and restart Sandbox. And good. We get here error messages. So we can see the error messages in the console. And this is part of really what Elm does. So it has very specific error messages. Here, we're saying the case is not branches for all possibilities. So when we have this case statement here, we have to include all the different possibilities in the message. So let's add the other missing possibility, which is we have a delta, and we're going to return a new value of -1. Now, in Elm, everything is immutable. So in this case, we can't tell that much because in most languages, integers are mutable. Right? You can't actually change a 2 into a 3. You can only create a new integer, 3 from 2. But we're going to see this example in a little bit. Made that change. Let's do a save. And we see hello. That's fairly straightforward. Now let's go ahead and actually output the value of our model. There's a string.fromInt. And we can just print our model, and let's try that. Oh, it doesn't like that. And the reason for that is that's a string again. We need to call text on that. Now here's a problem in that text is a function, and we have another function. We are applying this function and then taking the result of that and passing it to text. As things stand right now, it's a problem. What it's saying is text needs the first argument to be a string, but this first argument is actually a function. We can put parentheses around this. And now we get our counter. Let's add some more things in here. And let me show you how things are commonly formatted. When you have arrays, it's weird looking syntax, but it actually makes a fair amount of sense. Output the header. So we'll have an H1 with no attributes, and our value will be, let's say, it says counter. And we have a comma to separate that from the next element of the list. So let's put that here. This is one entire function called H1 that returns us our header. That's the first element of this list, which is the second parameter to div. We need commas to separate it from here, and you'd normally think, well, I'll put a comma at the end here. That's not how we actually do things in multi-line lists. The convention for formatting is we'll put the comma before, lined up with the open bracket here. And then this goes here. So our H1 and our text are aligned, and then our closing bracket is going to actually also go on the same column. So that we have our open, all our commas, and our close. That's the Elm convention, not required, but suggested. So we've got our text. Let's create a button. Let's just put the button name for a moment. We're going to use text plus and another button, text minus. Save that. Oh, it can't find H1. And the reason is we haven't imported it. So let's import it. And so now we have a counter with a 0, a plus, and a minus. Let's add a break. We don't have a break here, but let's add it. So our counter is separated. We increment, decrement, nothing happens. And the reason for that is we actually haven't specified an on-click for our button. Let's specify an on-click. We specify this, again, as a function. So on-click is an actual function. We're going to provide a message. And what's the message we're going to provide? We're going to provide increment. Now, increment needs to get passed also delta, which is the amount to increment. That works. And let's do a similar thing for our decrement. Here, our on-click will be decrement. And unlike in React and JavaScript, where you'd have to be careful on your on-click that you're not passing in an invocation of a function, here we are passing an invocation of a function, right? This is actually a constructor that constructs a message. We're passing in onClick and this constructor that constructs a message. But all that happens is all that really says is on a click of a button, take this message that's already been created and go ahead and return that to the Elm runtime, which will then go ahead and dispatch it to the update and then re-render. Let's make sure this works. Yes, it works. Let's look now at the immutability, because that's really important. Let us change model instead of being an integer. I want to go ahead and make this be a record. So a record is like what we might think of as an object in JavaScript. We have fields and values. In Elm, though, everything is strongly typed. So we actually provide our types. We're going to have in our model, let's say we're going to have just a count. So this is, in some ways, a silly record because we only have one field. Okay. I know. Let's add 2 items. Let's do the delta here. This is by how much we actually jump when we're incrementing and decrementing. If we go ahead and try this, it complains and it says, we wanted a curly brace. The reason is we do need commas here, and we're going to use the same funky formatting. Now it's not happy with the init because the init is returning a number, and this has 2 values that we need in it. We can't just use an integer to initialize a model because a model is not an int anymore. When we have a record, we can use this record constructor where we just pass 2 ints. We'll say the count is 0 and we're going to increment it by 5 each time. Now let's see, now it's saying the update. Let's just fix this one, the model +1. We're getting a message, and this is no good because model is a record, and so you can't add 1 to it. What we cannot do is say model.count equals model.count +1, because you can't change values of records. That's just not possible because of this immutability of Elm. Instead, what we'd like is a new model like our old model. Our old model is going to have a value for count and a value for delta. So we like is a new model, just like the old model, except count is incremented by 1. This is very similar to, we might think of it as if we were using JavaScript, something like the spread operator for model, and then we'd update the count to be model count +1. That's roughly what we're going to do. But we use the syntax of Elm for this. So I'm going to just put that syntax. We provide the record and then a pipe symbol. And then we say count equals model.count +1. And of course, this one should have been model.count. So the former is a JavaScript way. This is one we've seen where we don't want to modify an object. We want to create a new object with one modified value. We want to do that. And we don't want the +1 because we want to actually update by the delta. We want to use the delta that's coming in here. I suppose we could also use model.delta. It would really be very similar. We're going to do this with a -delta. We're saying init update in view. It's not happy. It's not happy because init update view sandbox needs the first argument to be. So it's complaining down at line 35 about the string from int model. This is not okay because, again, model is a record. We can do .count to extract that value from it. And then here, let's just leave the increment 1, decrement 1 for a moment. We'll come back and see what else we might do. And we're looking here, init update view. And the problem here is init function wasn't being called. We were initializing init with v0. We want init equals init. So we're actually using this function that we were never using before. So I apologize for that. So this was actually just saying, when you call the sandbox, init has to return a model. We were just returning 0. We want to call a function that will return our initial model. So this is working. Now let's go back to here. Instead of incrementing by 1, let's increment by model.delta. Yes, that's working. And while we're at it, let's just add another message, which is set delta, which will take an int. If we get a set delta message, then we want to modify the delta. Let's say this is coming in as the new delta. And so we want to set delta to be the new delta. What we want to do here, let's get some text. And we can see our delta is 5. That's good. We're calling text twice here with 2 different strings. On alternate thing we could do is we could create a new concatenated string. That works. And now let's just add ourselves a button that on click sets the delta. So let's say the delta will become 50 if we click that. Our text is going to be to 50. We can increment by 5. And if we click the delta, it now changed to 50. What this is really showing is just the fact that we can do records and how we work with records. Let's make another change. Instead of having one counter, we're going to have multiple counters. Since we're going to have multiple counters, I'm going to change the text here to counters instead of counter. And we are going to make our model be a list of these records. List takes a type because lists in Elm can only store specific types. You can't have a list that contains numbers and strings. They'll have to be the same type. In our case, this is going to be a list of these guys. In our initialization, we are going to return a list of those. Let's just see how that works. It doesn't like that way of initializing. Let's make this a little easier and call this a counter. A counter is the type here, and then we'll just make this a list of counter. What we can do is say our model, we're going to start out with 2 counters. One counter that starts at 0 and increments by 5, and another counter that starts at 99 and increments by 1. And of course, since model is a list, we don't provide the name here. We're just saying we have a list with the square bases of counters. And now it's complaining down below that here, this is no good. Right now, let's just think about this a second. This is, when we say increment, well, having a single integer is not enough because we have multiple counters and we want to know which counter to increment. Let's add an int here, which is going to be the index of which guy to increment. So we get given a model, which is a list, and we want to create a new list, which is like the old list with one element changed. We cannot just say model at index.count plus equals delta for 2 reasons. One, we have this record here, and you can't change the record because it's immutable. But not only that, the list itself is immutable. Once you have a list, you can't change any elements of it. Instead, we've got to do something similar to how we did in JavaScript with React, where we would go through and map the existing array and find which element we wanted to change, and then go ahead and create a new element for that. So that's what we're going to do. We're going to do a list.map, but we're going to do an indexed map because we want the indexes as well. That's going to give us pairs of indexes and values. And we need a function here. Let's just go write a function. We could write it outside. It's actually possible to write it inside as well. Let's do that. We're returning a single expression. But what if we need to create some temporary variables or something? Well, the way we do that is let. So let's just look here. We can do, for instance, let new value equals model account minus delta. And then we say in. This is all one single expression, but notice in this single expression, I can go ahead and create new variables. I could even create functions in here if I wanted. So I'm going to do the same thing up here in the increment. I'm going to go ahead and use let as a way to create a function that I passed indexed map. You can use lambdas, that is anonymous functions too, but I want to show you how to create a named one. So let's look at handle counter. Let's just provide the type of it. It's going to get given an integer which is going to be, right, index map is going to provide two things, an integer and then a counter. Let me just write the code down here for index map first. We're going to be passing in handle counter, and we're going to also then be passing in the list that we want. So the list is model itself. This is going to return a new map of the same size as a model, except each element in the model is going to be transformed by handle counter, where handle counter is going to give not only the counter, but also the index of that counter. So we've specified the type of it. Now let's actually write the code for it. The handle counter is going to get the index and the counter. And what are we going to do? Well, we are going to basically check and see if we have a problem because these two indexes are the same. So let's just call this counter index. And let's call this index to change. If counter index equals index to change, then what do we want to return? I want a new counter like the old counter. Something like the old counter, except we want the count to be equal to the old count plus delta. Otherwise, we want to just return counter. Okay, let's just notice one thing. If and else, actually, unlike, let's say, in JavaScript or in Python, this actually has a value. An if-else statement has a value, and it's the value of either the if part or the value of the else part. Notice also here, we can have, as I said, a whole value, which is the value of this expression where we get to declare all sorts of other things that we can use within that expression. And the scope, by the way, of the handle counter is just within this in statement. Let's just see what this says. So it says handle counter, and it's complaining about this, right? So we want to say that int goes to counter, goes to counter. And we apply these separately. So we don't say int comma counter, because the fact is every function in Elm that takes multiple arguments, you can actually just pass a single argument, and that will bind that first argument. And now you've got a function that takes one fewer arguments. Just as an aside, if we had, for instance, an add that took two integers and returned a third integer, the implementation of this is, of course, pretty simple. If we call add 3, 4, that's, of course, going to return 7. If, however, we have add 1, that's actually a function that will, so let's just try this. We could do something like add 1, and this is now a function which we could call an increment. It just adds 1 to something, and we could call that function on another value, like let's say 4, or we could just use this function and pass it around. So we could take the add 1 function, and add 1 is now something of type int to int instead of int to int. That's the reason that we have this, what looks very odd mechanism of handling the types for multiple arguments. Let's just see how this looks. It's saying new value equals model.count. That's down here, so it's complaining about. So we have a similar problem here. So let's just do the decrement. We do have a bit of an issue. Just this is a little bit ugly because our handle counter is looking so similar, and the only difference is this plus and minus. We can go back in a bit and fix that if we wanted. And then our set delta also has to take an index. We're going to have, unfortunately, similar code in here too, at least for the moment. If it's the index to change, we want to change the delta to be the new delta. And this gets a index to change, and this gets an index to change. Now let's just see how we're looking. Now it wants this to change, right? So it's complaining about model.delta. Here, we are going to want to actually map over all of the items in the model. All of this code here, we're going to probably want to extract out into a function. Let's do that. And let's say counter view. That's going to take a counter and return a parameterized type. This is the HTML that takes a message type. So this will be our counter. And we are going to return a div. This counter has a counter.count, counter.delta, counter.delta, and we need a closing there. Let's see how we're looking. So text string from int counter.count. Oh, we're right here. And the reason is we have a comma here. That's no good. And now it says, unfortunately, this is yellow. I can't see. So it says the div call produces HTML int to message. It should be an HTML message. So let's look and see why that would be. Oh, and the problem it has here is it's actually showing me right here, I think, in here. This error message wasn't too great, but it's showing all these counter.deltas. And we actually need, basically it's saying all these messages are just taking one parameter. And we actually need more than one parameter. It's saying that we've actually generated an HTML int to message. Because in order to finish this, to make this work, we have to apply another integer. Let's modify this counter view. So we're going to take a counter and we're going to take an index. So that's going to be an integer here. And so we're going to have the index. And so we'll pass in this counter index here and here and here. The int type needs 0 arguments, but I see one instead. Let's look. And that's because, of course, when you have multiple parameters, you don't just put them like so. Why did this work? Because we're not even calling this function because we're not doing our map yet. Let's do our map. Let's provide one more div here. The second parameter of div is a list. Well, we can just do that with list.map. What do we want to map? We want to apply this counter view function, and we want to apply this to our model, because remember, our model is a list. And h1 expects 2 arguments. So we did an h1 here. We failed to put a comma. Now it's complaining that div has 2 parameters. I have a div. Second argument to div is a list. Map produces a list, but I need to actually call map first. And I can't call map because I actually need the index to go in. It's not index map, it's indexed map. And there we go. Now we can see we have independent counters. Let's just make one more quick change. Let's add a header. Okay, so let's see, since we're short of paren, which we are, and we don't have an h2, and we can number 0, can number 1. Finally, what I want to add is a way to add a new counter. Here, after the header, we will have a button, we'll add a counter. We should get an error because we don't have such a message. Now we get an error because the case doesn't have the name to support it. And what we're going to do, model is an array of counters. So we'd like to create a new counter. We can concatenate lists with plus plus. So as long as I have a list here, and I'll have a counter that starts at 0 and its delta is 1. We can see we can create counters. So that is our introduction to Elm.